Assalamu alaikum wa rahmatullahi wa barakatuhu. So in the previous video we have seen the voltage regulation and the effect of power factor on the no load and full load voltages and we have seen that by phasor diagrams that how they affect the voltages. Now we will move forward a little bit. So far, we have seen the turns ratio of a given transformer were completely fixed. But in almost all real distribution transformers, this is not quite true. And the distribution transformers have a series of tabs in the windings to permit small changes in the turns ratio of the transformer after it has left the factory. So these transformer tabs are usually given such that if there is a small voltage variation that occurs due to the transmission, that can be catered there. So we don't have to put another transformer, and that's why we put a small tabs in there so that we can have the proper output voltage. A typical installation might have 4 taps in addition to a nominal setting with spacing of 2.5% of full load voltage between them. Such an arrangement provides for adjustment up to 5% above or below the nominal voltage rating of the transformer. So this is usually, I've told you that we need to do it for various reasons, and because of the voltage drops that occur due to the transmission and all those effects. So the taps on the transformer permit the transformer to adjust in the field to accommodate various variations in local voltages. However, these taps normally cannot be changed while power is being supplied to the transformer. So they must be set once and left alone. Sometimes a transformer is used a power line whose voltage varies widely with the load. Such voltage variations might be due to high line impedance between the generators on the power system and that particular load. So the normal loads need to be supplied an essentially constant voltage, because if we have a variation in the voltages, so sometimes we look at some in our homes that during a high demand time or the peak time of the load, so we usually experience a low voltages. Sometimes it reduces to 220 volt, or from 220 volt to 200 volt, or sometimes it even goes to 180 volts. But most of the equipment that is actually designed, they are for 220 volt. So we have to put some security in between them such that they may not damage the equipment, just like the voltage regulators or automatic voltage regulators. So they can essentially increase the voltage up to the 220 volt. But sometimes now the devices are manufactured which have the possibility that they can operate from, say, 200 volt to 240 volts, so that variation of 40 volt plus minus 20 volt may be catered by the device itself. But however, usually we need a constant voltage for the load. So how can a power company supply a control voltage through high impedance lines to loads which are constantly changing? So one solution to this problem is to use a special transformer called the tap changing under load transformer or voltage regulator. So basically a tap changing under load transformer is a transformer with the ability to change taps while power is connected to it. So most of the people might have experienced these transformers at home, which we normally called as the voltage regulators. Voltage regulator is a tap changing under load transformer with built-in voltage sensing circuitry that automatically changes taps to keep the system voltage constant. So such special transformers are very common in modern power system. So we call them mostly the AutoTransformer. So on some occasions it is desirable to change voltage levels by only a small amount. So for example, to increase the voltage from 110 to 120 volt or from 13.2 to 13.8 kV. So these small rises may be made necessarily by voltage drops that occur that occur in power systems a long way from the generators. So, in such circumstances, it is wasteful and excessively expensive to wind a transformer with two full windings, each rated at about the same voltage. So, special purpose transformer called an auto transformer is used instead. So, in auto transformer, here we can see that we have only one winding, and this tab is movable, so that can be adjusted over this winding at any point unless we reach the required voltage. So these transformers you might have seen in laboratories in different experiments where we call them as the variac or the variable AC source or the variable transformer. So these are the auto transformers which we can use instead of winding if we require. So that is a auto transformer. So almost all the major power generators, generation and distribution systems in the world today are three-phase AC systems. So these auto transformers are generally just the variable AC sources, so we can use them. So you might have seen obviously in the lab, and you will be, if you have not seen, so you might be seeing these variacs in the electric machines course laboratories. So you will inshallah experience with these variable transformers. So I will stop here with this video, and if you have any question, please feel free to ask. Assalamu alaikum wa rahmatullahi wa barakatuhu.